Okay, so all things in nature, you can find it in one of these three states. Well, there are some others, but for now, we're just going to concentrate on these three, which are solids, liquids, and gases. So a solid is just uh, a state in which all the particles are very close together, and you can think that they are tied to each other by these little forces, these spring-like forces. And the nature of these spring-like forces have to do with molecular interactions and electromagnetic interactions. We won't go into those details, but to simplify the picture, you can think of this as you can think of a solid as particles being tied together by these springs, right? And then uh, what that does is that each particle is kind of particles are stuck on this side. They won't move too far away from this side. They are going to be on this side for most of the time, and all they can do is vibrate. So now, if we hit this system, right? If we hit it, what's going to happen is some of these springs are going to break, some of these bonds are going to break, and then we get what we call a liquid. And in a liquid, the particles are a little farther from each other and they are freely to move. They can freely move on the container and uh, and they exert pressure and they flow now. Solid in a solid, the system doesn't flow; it just stays there, right? So in a liquid, you can see that it flows and it sort of fills the container. And then if you keep heating this, you're going to get a gas. In a gas, all the particles are now far away from each other, and gas is a fluid that is highly compressible as opposed to a liquid which is incompressible. Incompressible means that it's very hard to change the volume. So solids and liquid are nearly incompressible as opposed to gases which are very compressible. It's very easy to change the volume of a gas. Let me remind you of the idea of density, which is mass divided by volume, and the units of densities are kilograms per meter cubed. And we are going to be using this quantity a lot. And here is another table with some common densities. This is air, which is 1 kilogram per meter cubed. If you take a box that is 1 meter here, 1 meter here, and 1 meter here, and that box contains air. The weight of that box is 1 kilogram. If you put water on that box now, it's going to be 1000 kilograms. If you put if you put solid water, then that's 920 kilograms. And you can see that the density of ice is less than the density of water. This is the reason that ice floats in water. And so we have another elements here. We have copper, we have gold. Look how heavy gold is. Lead is also very heavy. Mercury and silicon. So all these densities are at a temperature of 0 degrees Celsius and 1 atmosphere. Density is density is defined as mass divided by volume. But sometimes we'd like to use a quantity called number density. And the number density is just the number of atoms in your system divided by the volume. So this density has units of kilograms per meter cubes. This number density has units of 1 over meter cubes simply because this number here is just the number of things, of atoms in your system and is not going to have units. Here is a quick question, so take a minute to answer this. What is the volume of the cube? And if you did this right, you will get that it's 10 to the minus 6 meter cubes. And the way you do that is that you say 2 centimeters is equal to 2.0 times 10 to the minus 2 meters. That is a centimeter, right? That is, and then when you take three of those, you'll get minus 2, minus 2, minus 2. That gives you this minus 6. All right, thank you very much.